Don't be surprised, be prepared if recurring decimals to fractions comes up in your maths paper 1 tomorrow. Let's go through this question together. So it says work out 0.72 recurring multiplied by 0.6 recurring. And the way that we do this is we convert these recurring decimals into fractions, we multiply the fractions, and then we get our answer. So how do we convert these into fractions? First thing I want you to remember is we're going to call each of these x. And let's start off with 0.72. That's the one we're going to convert into a fraction first. So I'm going to say x is equal to 0.72 recurring. And if 7 and 2 are recurring, that means this would go on being 72, 72, 72, dot, dot, dot. The first thing that you need to do after you write down x equals 0.72 is figure out whether you now need to work out 10x, 100x, or 1000x. And the way that you do that is you look at how many recurring decimals there are. If there is one recurring decimal, you'd find out 10x. If there are 2 recurring decimals, then you work out 100x. And if there were 3 recurring decimals, we would work out 1000x as our second step in this question. Now I can see that there are 2 recurring decimals, 7 and 2. So I'm going to do 100x next. 100x would be this multiplied by 100. So move that decimal place forward 2 spots, which will make it 72.727272 and so on, right? Because the 7 and 2 are recurring. The next thing you do after this is you write down the x value underneath it, which was 0.727272 forever. And you subtract these from one another. So at this point here, I can do 100x minus x, which gives me 99x, is equal to, and then I subtract all of these. And notice that what happens is every single one of the recurring digits, if you've done it correctly, will cancel out. So all those recurring digits are gone, and I'm left with 72 minus 0, which is 72. That's what happens when I subtract them now. So the next thing I need to do now is divide both sides by 99 to just get x on its own, solve for x. So that gives me x is equal to 72 over 99. And I can simplify this to make my life easier when I'm multiplying them later. I could divide both the top and the bottom by 3. You can use the bus stop method here, or you might know that that's 24 over 33. And I can divide this even further by 3 again. And that gets me 8 over 11. Now, I've got my first one. 0.72 recurring is 8 over 11. So I can move on to the 0.6 now. So I can say x is equal to 0.6 recurring. You can use a different letter if you find that confusing, but I'm going to stick with x here. X is 0.6 recurring. I can see that there's one recurring decimal, this 6, so I need to find 10x as my next step. So I can say 10x is equal to, multiply this by 10, that gets me 6.6 recurring. And I write down the x value underneath it, just as before. So that was 0.6 recurring. You don't have to write all of these out, I'm just demonstrating. And then we subtract these. So I've got 9x, because 10x minus x is 9x, is equal to, all of these recurring decimals will cancel out, and I'm left with 6. At this point, I just have to solve for x, so divide both sides by 9, and I can see that x is equal to 6 over 9, and I can divide both the top and bottom by 3, which gives me 2/3. So 0.6 recurring was 2/3. We may have already known that x equals 0.6 recurring would have given us 2/3, but this is really good practice for numbers that you might not know the value of instantly. So now that we have this, I can do the final part of my question, which asks me to multiply them together. So 0.72 recurring, which I figured out was 8 over 11 from over here, and multiply that by 0.6 recurring, which I figured out was 2/3. Multiply these two fractions together, that's 16 over 33, and that would be my answer.